Hey everybody, nice to meet you all. My name is Ying. I'm a senior data engineer at Motor Refi. We're an auto refinance company based out of the Arlington, Virginia area. Been working professionally for the past 4 years at three different companies and took a little sabbatical thing last year, all of them in the DC metro area. And primarily I am focused around Python historically. The current company I'm working with is mostly like SQL, Ruby, TypeScript, and functional programming and stuff like that. But yeah, very interested in Python. Very have some experience there, and wanted to give this talk, I guess, in order to prime my own skills about project-based testing. Cool. So with that, I guess we can go ahead and jump in. Let me go ahead and share my screen. Share screen. To share. All right, so property-based testing in Python. Let me see if I can selected. Cool. So I actually made a small GitHub repository that you can clone. It's called PyDistrict_PBT, and it should be available at my GitHub account, YingW787. So yeah, feel free to clone the repository, check out. I guess check whether or not you have the system dependencies, and then start the Docker container, warm up your Docker cache if it suits you. Well, so with that, let's begin. So running tests today kind of sucks. So tests are kind of expensive to write. They're expensive to maintain. They're somewhat opaque to people who aren't really intimately familiar with the test harness in the first place. And you can't always really be sure about whether or not you're writing the right test for your situation. And worst of all, it's sometimes really hard to persuade a non-technical stakeholder that software testing actually does anything underneath the hood, except maybe like inflate your OpEx for your software budget. Every software development horror story I've kind of heard around or experienced has come with some discussion around tests. And that's because not only does software fail in more ways than anybody without job security cares to admit, it fails in novel and unpredictable manners. So what sucks even more is just how important effective software testing is. The first thing that I do when cloning most of the repositories these days, after installing whatever dependencies I need to, is to run the test suite. Test suites are usually self-documenting, and they're always more accurate when they're working than a wiki or other forms of documentation. And since they're programmatic, they can tie easily into the rest of your developer workflow, say if you're doing automated deployments in CI. So this probably isn't news to you if you've been working in the industry for a while, and it's easy to fall into like a mental trap of powerlessness. And while it's not usually like the fault of technical limitations of being in a certain situation, it's useful to think about technical ways in order to grow beyond the immediate problem. So I'd like to say that there are two great aspects about professional software that can be applied to software testing. The first is that software development is usually incremental and is incrementalist in thinking. So that usually means that there's concepts in academia or research that might apply to solve current problems. Like one example is that one professor I was talking to right after graduation from college was talking about how the A-star pathfinding algorithm was invented around 20 years before it was adopted in the video game industry. And that's why NPCs don't collide with in-world walls anymore, for instance. The second reason is that test suites usually fall under the full control of engineering. So, for example, sales and marketing might care deeply about how you configure the layout of a landing page, but they don't usually care about how you structure a test harness. And so, while serving the company is important for any like oriented engineering department, there's usually more agency than usual in how engineering approaches testing rather than, say, product implementation or DevOps. And so the metric that I would be looking for in terms of writing tests is to have software engineers write as many good tests as possible within some limited time frame. So there's a number of ways in order to write great software, right? The first thing about writing good tests is to have good source code to test in the first place. So that might mean, say, separating concerns out in the code base or by using, say, functions instead of classes, applying type signatures using MyPy or PyCheck if you're in the Python world, and adding a type checking step within your CI pipeline, paying attention to software properties like immutability or idempotency, And you could bring a lot of value, I think, just by bringing some of the other tools within the software ecosystem, such as, say, Rack in Python for auto formatting, or Docker Compose for running local infrastructure. And a lot of this, I think, undergoes higher order testing strategies, like property-based testing later on. So a lot of these, some of the strategies I've applied in the field revolve around some of these simpler ideas. So if you're building, say, like a web app or a web-based microservice, for instance, you can apply the idea of like a functional soup imperative shell. So you have a soup of each couple methods and business logic within your app that's easily unit testable, and then a set of well-defined I/O interfaces and stubs to imperative resources like, say, your network, your disk, to create the cheapest possible integration test. So this is nice for like stateless pass-through entities, but it works less well if you're primarily testing side effects. So if you're trying to test, say, a database, unit test might not be the great fit. Might not be a great fit. So when I became a data engineer, my second job, and I was owning an ETL pipeline, and I was primarily spending my day interacting with vector systems, I attempted to write like some data-driven integration tests using PyTest and leverage its ability to parameterize over data in order to create a Mongo dump of test descriptions. So it was nice in the sense that it allows me to scale my data far beyond the amount of code I need to write for my test targets, but I still need to come up with my own Oracle values in order to test with. So it's very easy to run an expensive integration test with very little added value. So that's partially where my interest in property-based testing stems from. So I would mention that even with property-based testing, all these other testing strategies have their place and their trade-offs. So you should decide for yourself when to apply which. Cool. So what is property-based testing? So at its core, property-based testing is kind of like the inverse of normal unit testing. So instead of providing some amount of data and a transformation so that the computer can assert a property, you provide the property and the transformation so the computer can fly using data. So if you go back to the basics, you have a method, say, add 1 to increment an integer by 1. So you have x returning x plus 1. You can test this method by defining a set of unit tests. So let's say you have a method test1 and you want to assert that add1 5 is equal to 6. So this would be a very basic unit test in PyTest, for instance, right? You can parameterize this test harness by adding PyTest mark parameterize and a list of expected input values and expected output values. So you have 5, 6, 6, 7, 7, 8. I would expect the first value within each tuple when applied to the add 1 to equal the latter value, for instance. So the final leap here would be like, instead of coming up with your own Oracle values, just care that the inputs are integers and that the outputs are functional deterministic transform of applying that integer input to result in an integer output. So that's where property-based testing comes in. So you have a strategy, you have some integer strategy, for instance, here, st.integers. If you're applying that to the method test add 1, you can assert that the input is going to be equal to input plus 1. So this is pretty much just rewriting add 1, but it's doing so in a way where you're applying the output property, like the integer is going, the integer output is going to be the integer input plus 1. So for some properties, you can apply, say, like an opposite transform. So the opposite of, say, addition would be subtraction. And if you apply both of them together within the same method, you will result in the identity method. So if you're applying, say, add 1 and then subtract 1, you would expect to get the same result back. So you can define, say, the method sub1, which would be x minus 1. And then within a separate test method, given, I guess, some listed integers, if you're adding 1 to the input and taking that output and then subtracting 1 from it, you should expect to get the same result back for all possible integers. Right. So what else is property-based testing similar to or different from? One of them is generative testing, which are tests that create tests. So since we're creating like a speculative hypothesis, is generating tests underneath the hood for us, and then running them. Probability-based testing using hypothesis is a little bit different because it supports intelligent search strategies and shrinking of the, I guess, the error space, as they call it. Another testing paradigm similar to property-based testing is fuzz testing. So that's where random inputs are inserted into a program to see how it behaves and whether or not it crashes. So from my perspective, interaction with fuzz testing out in the field, there seems to be more integration testing rather than operating at the unit test level of property-based testing. So hypothesis specifically is one of the more popular implementations of property-based testing in Python. When I first started off learning about hypothesis, maybe 2 years ago, I thought it had originated from a library in Haskell called QuickCheck. And indeed it is, has QuickCheck as one of its ancestors. But a closer ancestor reveals that hypothesis comes from a PDT library called Hedgehog in Haskell. So Hedgehog is a little bit more of an advanced version of QuickCheck, and that's where the concept of built-in shrinking was introduced as part of the test generation suite. So yeah, that's links to the hypothesis documentation and I guess the hypothesis consulting firm started by the maintainers. Yeah, so the key idea behind hypothesis is strategy generation. You can see examples of it, I guess, by running a small code sample in your Python terminal. So if you just import, say, from hypothesis import strategies as ST, as we did before, there should be a number of different, I think different strategies if you just tab autocomplete for ST. So yeah, so simple strategy being mapped directly to the Python values. So if you're doing st.integers, that will give you a stream of Python integers. That will vary you. So some more complicated strategies that you can do with hypothesis is, say, merging two different strategies together. So if you wanted to apply, say, integers or text, you can do st.oneof. You can define strategies using Python functions in order to generate certain amounts of data. You can infer, you can generate different kinds of strings using, say, st.fromRegex. And you can apply, I think, nested or recursive data using st.recursive. So these are all, I guess, different ways you can generate data using hypothesis. So st.whatever, I think, will generate a stream of, I guess, whatever data that you want to specify. So these strategies, I think, communicate some number of tactics you can apply with property-based testing in Python. So some of them might be, round-trip identity checks. Some of them might be, I want to check whether or not this method is idempotent. So applying let's see, a multiplication by one method, for instance. Doing that for any integer value should result in the same integer value. You can do, say, a number of liveness checks. So taking the maximum of the empty list results in, say, a value error because there are no values within the empty list. So all these checks, I think, all these properties, I think, start coming at you when you start working with these hypothesis strategies. There's other kinds of tactics that I think hypothesis does support. Some of these include, say, metamorphic testing or hyperproperties, but I don't really understand them all that well. I think there are some pretty great resources out there. One of them includes, I think there's one guy called Ying Wang. He has a pretty nice blog about combining, say, hypothesis testing with contracts, for instance. So this is all well and good, but for me personally, I like to work through real-world problems in order to try and solidify these learnings. So I took the opportunity to create 3 and probably completed 2 real-world code samples so we can discuss how to implement property-based testing for each one. These should be listed in the PyDistrict PBT repo as well. So the first example that I kind of want to talk about was a password validator. So there would be, say, some password validator that would take in an input string, which would be your password, and apply some number of business rules. For instance, it must contain, say, a minimum of 8 characters. It must contain a special character, uppercase character, a number, etc., etc. So these rules might change by a particular code base or context. And you can just say that, it takes in a string input, applies some set of gates, and I want to get a Boolean output value out. So when you describe it like that, it doesn't really appear a whole lot different from the other methods that we described before in this presentation. The way we might unit test, say, such a method would be having some password string that you will, I guess, pass into your test harness, and some kind of a Boolean output that you would expect. So I know that an empty string would return false. I know a string just of uppercase letters would return false, and so on and so forth until I have a string that represents all of the properties that I want represented within my password, in which case I will return true. So the property-based testing approach, you could apply st.from regex in order to specify the exact type of string that you'd be looking for. So this regular expression would take into account, like, you need to have one number, an uppercase letter, a lowercase letter, and a special character, and has to be 8 digits long. And from this regular expression, you'd be able to generate, say, a string that will be passed into your test method, and then assert that your password is going to be valid. So one thing that I use for regular expression testing in particular is a site called Pyfex, where you can punch in a regular expression and then some input and then see whether or not there's a match. So that is probably is it for password validation. The second example that I might want to go over is, say, a basic web app or a microservice. So you have some REST API, and you want to, say, issue a SQL command at the end of it, based on some input parameters or patch headers or what have you. So yeah, you might want to test this, say, using like a functional SQL imperative shell kind of approach. So this might be, say, a very, very basic integration test. If you hit a particular endpoint, say client.get init, this might say initialize database, for instance, and assert that the response would be 200 OK. And if you're hitting, say, an endpoint, say /test, and you're passing in URL parameters, say name, TED, and age 25, that might apply, say, an insert into SQL command and then return HTTP 200 OK. So with this kind of approach, you can see that that it works for simple inputs, but for more complex inputs, any string that might require, say, URL encoding, for instance, might fail. So this happens with names, for instance, because names can have special characters, and we might be able to handle testing for the service to sanitize these kinds of inputs with a property-based testing approach. So pretty much any byte stream, I think, can be a legal name. So you can use a particular regular expression. I think this one is slightly incorrect. I need to update this. But instead of, like, say, W plus, you can pass in, say, a regular expression that respects, say, like suffixes and prefixes. If you apply, say, like a filter to a number of integers, where you only want to have the integers that are greater than or equal to, say, age 18, if that's a check that's important to your microservice, you can do so. And you can tie in, I think, chain in a number of strategies and filter applications to these strategies as you want. So you can say that, I want to test that the endpoint test returns OK with these arbitrary inputs. I want to be able to parse out, I guess, these names and the particular age, and then parameterize them within my URL string. if I wanted to apply this URL string to my client, I should be able to get an HTTP 200 OK response back. So that's one way that you might be able to generate data for more of an integration test approach. I made a third example that I didn't have time in order to complete out fully, but within PyDistrict PBT, there's a file in order to create a data pipeline. So it streams, I think, JSON files, JSON data from multiple Python processes to a single log file. I guess my challenge there would be building out some kind of a log aggregation tool in order to apply PBT testing to these logs as they stream in from different devices. I added in, I guess, a neat little feature called, I think, clock scheme. So these records are ordered by device, but they're not ordered globally. So you might have to apply certain properties in order to assert ordering by device versus global. So that's all I've got, I think, for this presentation. These are kind of like really quick whip of examples about how to apply property-based testing, but hopefully it does give you some level of an idea of how you might be able to apply property-based testing within your workplace. So I really like the use of property-based testing primarily because it changes your mindset around programming. It makes you think about things not just from the way of the critical path, but the way of the state space of all possible paths. And so it helps you, I guess, mentally guard against certain classes of errors by building out better programming habits. That's it. That's all I got for this presentation.
Awesome, thanks, Ying. So everybody feel free now to kind of open it up for dialogue. I know some of you had emailed with some questions you're interested in learning more about. So we'll just kind of open it up to time for people to chat and ask questions.
I think that's very powerful. I didn't know how powerful hypothesis actually was. I was messing around. I've been messing around with PyTest parameterization in the past, but I always thought it was a sort of a limited to your inputs. But hypothesis seems like it's bridging that gap between all of the tiny missed test cases that you're not thinking about. I would have one question though. When you're talking about the stream of, say, a stream of strategy, integer strategy, would that iterate over every integer until you told it to stop, or is it sampling from representative integers like low and high?
So that's a really great question. There's, I think, a number, like a default number of tests that hypothesis runs is something like 300. And usually what it does, it tests, I think, edge cases first, because edge cases are the ones that the programmers usually build the test for. So the first value, I think, that comes from the integer strategy is 0. And then it might be, say, like in 16, like 2 to the 16, minus 1, or negative 2 to 16, plus 1 or something like that. In order to test like integer overflow, and then it kind of just works through like the rest of the integer state space. I'm not quite sure how exactly it works underneath the hood, but I know it tests the edge cases first. Like I think that goes for a lot of the hypothesis testing strategies. Like for strings, for example, it'll test like Unicode characters first and see whether or not you're handling like Unicode versus ASCII. So there's a lot of those things. But usually I think it caps out in around like 300. You can ask it to, I think, run more tests. It'll just be a little bit more expensive.
There's another cool thing that hypothesis does, that it actually caches previous results of previous runs. So if it, for example, finds that your function for whatever reason fails at the value of 7, it's going to add that 7 to that sort of list of usual suspects. So it's not going to just use the usual use cases, the usual edge cases, but it's also going to sort of augment it with your prior finds. So it effectively learns as it goes. So that's the good part. The bad part is, well, how do you make it work in a CDCI where everything gets stood up from scratch every time? You have to somehow it's good for more local environment. For automated, not that great, but I'm really happy to see that it sort of learns, it picks up things as it goes.
That was going to be my question. Is there some mechanism for storing the state that it's caching?
It does it automatically. It doesn't even tell you, it just does it.
No, I mean, if I wanted to integrate this into a CI/CD system, is there some mechanism to take that cache?
You probably can, I just haven't dove into it. I mean, it's ultimately it's just files. So if you can store files in a repo or something, then they're going to come along.
So I know, like, if you run talks, that stores it like in like a local directory, like relative within the repo usually. Is the same thing here? Is there like a dot hypothesis?
Yeah, I think there's like a dot local something, like the hypothesis or something, yeah.
Okay.
If
I can interject.
It does a lot of local caching, yeah.
If I can interject real quick. So I think the first thing is, depending on what your use case is, if you have a small environment where you don't have a large CI/CD pipeline, this will work just fine. I mean, me personally, I would never work with PyTest. I would work with unit test strictly. I would mock out what I'm specifically working with in unit test, and then I would use Ansible to work with my integration tests to test all of the different systems and functions around it. I just think that's a more automatable, a longer, more scalable solution to a more mature product or organization. But again, you know, there is no right or wrong here. There are many different, you can use PyTest, you can use unit test, etc. But I just think unit test in combination with Ansible will really get you your best possible testing environment. But that's just my 2 cents.
I noticed on the website for Hypothesis, there's a feature called Ghostwriter. Maybe could you comment a little bit on Ghostwriter? If you're not familiar with it, no problem.
I'm not familiar with it, no.
Oh, cool. The other question that I have is there are times that we really need to build more complex structures, like these document-like things with aggregates, lists, etc. So maybe explaining a little bit the expressive power of Hypothesis to build such structures. And then when there's a failure, the ability to kind of pinpoint the exact structure that was the one causing the test to fail, and then capturing that. I think that would be interesting for everybody.
Cool. Yeah. So the question is whether or not Hypothesis can extend strategies from the simple ones I described to more complicated ones. And I believe that is a feature that Hypothesis does support. I think it's called st.recursive. Like I would look into that. That would, I think, allow you to define, I think, arbitrarily nested, say, dictionaries, for instance. I think Hypothesis also supports generating, I think, it might be binary data. It might be some form of data with st.data. So there's a special, I think, data-centric strategy. And then I think Hypothesis also has third-party tie-ins. So if you want to generate, say, a randomized, say, like pandas data frame, for instance, I think there should be like a third-party integration for pandas in Hypothesis, so that you can generate like a strategy for that too. And there's also, I think, there should be a way in order to generate a strategy from a Python function. So you can template in a Python function to generate some random amount of data, and then that'll take care of probably the edge cases that that there isn't like a custom integration for.
Dot build, I think, build or builds is the strategy name that lets you splice together just about anything.
Cool. Thanks.
So I think Andrew has a question. So do Hypothesis test the inverse condition? Are the assertions if or if and only if? So I believe, sorry, go ahead.
Yeah, I wanted to just maybe elaborate on this, like the specific use case I was thinking. In that regex example for password matching, what was it like? I was assuming that like you showed, like, for example, the unit test, which you had examples that both should return true and false, but it looked like with the Hypothesis, you'd only test things that should return true.
That's a good question. So I'm not quite sure whether or not Hypothesis might work with, say, PyTest mark parameterized. So you might have, say, to create like two different unit tests, one is certain true and one is certain false. But I think hypothesis is primarily around the data generation aspect. So I think you can apply any kind of assertion within like a test that uses say hypothesis not given. The inverse condition being true or false, yes. So I'll just break that out. I think if you can't find a way then to parameterize them both in the same test. And assertions if yeah. So the assertions that you can find whatever assertions you want. That's
So is there a way to specify like from regex, like specifically this like generate a string that doesn't fit this regular expression?
You could just negate it.
Yeah, true.
That's what I would do.
So speaking of regex, regex itself is a terribly, notoriously difficult thing to get right. So like you were showing an example of how you use regex to specify the strategy. I'm more interested in how do I actually test regex as I find all over the place to make sure that they do what they actually intend to do. Because like my favorite example, because I've actually seen it not only in the wild, but this is actually taken from a security product, funny enough. Someone was checking the format of an IP address with a dot in regex, which means one character, any character, right? It doesn't actually mean dot. They forgot to escape it. But it worked because any one character also matches a dot. So it kind of worked until it didn't.
So I think I use this.
How would you write a property test, for something with dots, let's say, like an IP address?
You can use, I think, regular expressions for that. So I typically use, I think, this site called Pipex. And Pipex is kind of like, it's like just like a web app where you can punch in like a regular expression and then some test data. So for your example, in say generating a regular expression that tests IP addresses, you can punch in like a certain number of like valid IP addresses, and Pipex will highlight that it found a match for that particular regular expression. And then you can also punch in, I think, a set of invalid IP addresses or just complete other strings. And it can say like I did not find an adequate match for this particular I think the string for this regular expression. If you didn't want to use regular expressions, and I learned this, I think relearned this I think yesterday. I think hypothesis does have like a general like a text string strategy. So it would be like st.text. And that would just generate things like a randomized data stream. And I think you can chain, I think, different kinds of gates together for that data stream, so you can apply different kinds of filters. I'm not sure whether or not you might be able to filter an arbitrary like text stream into like IP addresses. So you might have to start, I think, with the st.regex in order for hypothesis to generate like accurate data out of the gate. But if you have, say, like, if you just apply, say, regular expressions, say I want any kind of string, but only say like 8 characters long or more, you can apply like a lambda function to that text string, to like a text string instead, and say like I want to filter out any string that is not like 8 characters long or more. So I guess it depends on I guess your certain use case, but I think for like IP addresses,
what was your general strategy for testing regexes? Let's say you get a piece of code that you didn't write. The regex is long and ugly, and you just want to, it's got the code smell. You have a feeling that it doesn't work right. How would you go about beating it up with hypotheses or whatever other tool?
Can you say that question one more time?
Like, if you have a piece of code with regex that that you're not an author of, you don't know whether it works right, and you just want to beat it down. You want to see, whether it actually does what it's supposed to do. What's your generic strategy for testing regex?
So my generic strategy for testing regex, it's a good question. I haven't been placed in that position before. I think mostly in my career, I think I've been like learning tools that I've written, and so a lot of the tests and the regular expressions I've written in my workplace are just things like I've written like myself 6 months ago. That being said, if I was to test like an arbitrary like regular expression, I'd probably just take like pieces of it and put it into I guess PyText, and then start like filtering out like what's an invalid input for like a certain say like group, for instance, if the regular expression has groups. And if it doesn't, then
Can you do something like that with hypotheses? Like, here's the general regex, but generate me a string that would invalidate it. Can you? I mean, that's kind of. I mean, that's what a lot of the hypothesis is for. Literally, find me a invalidating example. But with regex, the key space is just so gigantic usually that it's much harder to do. So how does hypothesis tackle things like regex? I mean, do you literally just feed it text and hope it hits, or is there a more targeted way?
Yeah, I think for one-off ways in order to test regular expressions, and I think this goes for any kind of strategy, there's usually like a dot example, like an example method on the, I think, specific strategy subclass. So you can call dot example and it'll spit out one, I think, one string, for instance. And if you do that enough, or I think there might be like a separate method to generate like a string, you can see like the actual like strings that are spit out by that hypothesis strategy given a specific regex. And so that might be like a way in order to verify whether or not your regex is producing the expected behavior. Does that help answer your question?
Yeah, maybe I can add on top of that. I think I understood the question as meaning the statics will parse the regex, kind of understand its components, and then try to first produce something that satisfies the regex, and then produce something that do not satisfy the regex. So then you're trying to kind of test its mechanics, validate it, and then test its extrapolation power if it's going way beyond. And I think that is feasible to some degree, but then again, there is the issue of the semantics of the regex, which was implicit in Marcin's question.
Yeah, like the example with the IP with dots,
Exactly.
It's a good example because, 1.2.3.4 is technically valid input and it will pass the regex, but that's not what the regex actually says.
Yeah, what I think
it would also take 1A, 2B, 3C, 4. Because it will take literally any character as long as it's single.
I think what's behind your question is that once you write the regex is a language. So you're trying to express a lot of things that it can produce, but there's the semantics of that. And for testing the semantics of that, we would need a way to express the semantics and expectations on the semantics in another way other than the regex itself. So, that's
what I've done with it, just to maybe give you an example of how I've been trying to use hypotheses for this, is basically I have it generate examples.
Right.
Because when you tell hypotheses to give you something that that does go through the thing that you're testing, which in this case was regex, it would spit out a bunch of strings, and most of them would look like an IP address.
Mm-hmm.
I'm confused.
Just by visual inspection, you can literally see that there are things in there that are not IP addresses.
I'm confused by this example though, because why can't you just escape your periods and your regex so that you make sure you're...
Because the period didn't mean a period, it meant any character.
Not if you escape it in the regex. You can escape
it was a mistake, I think.
But they didn't.
It was a mistake that he was trying to catch.
Right. He was asking
the bug.
To test to catch the mistake.
Right, okay.
Because the regex is the thing under testing not any specification to support another test.
Yeah, yeah, you'd have to do something, as you said, you can't test regex with regex, so you have to do something like assert that this has 3 periods in it.
Which kind of breaks the whole premise of hypothesis where you're randomly generating. Makes sense.
So I guess I could speak a little bit about this example, like what happens if like is this what happens if like my hypothesis test may not be entirely correct. I've used hypotheses, I think, in one location, I think at work, at my previous location of work. And there's four passive validation approach that I was talking about here. And it wasn't necessarily like a pure hypothesis approach. I first like created like a number of PyTests against like assertions. So it was like the PyTest like Mark parameterized approach before. And then when cases like weren't caught, I think by these, they like if I was trying to input say like special Unicode characters, then that would be where I would apply the hypothesis test. So if there was like an error in hypothesis, or like if I was having like a Regex error, it wouldn't necessarily break like everything within my test suite. Like it'll like I think the relatively like simple cases, like if I was just checking say like string length, those would still I think be caught by other tests. So it's not necessarily like a one like a all or nothing kind of approach. You can combine both of them and you can run them using the same command with PyTest.
I've got 2 questions. One is the generation of test cases or generation of inputs. Is that deterministic? And is there a way to, if it is there a way to basically be able to rerun that set of inputs?
Yes, you can save seeds.
Yeah, I think with random seed you can explicitly set within your one command.
And then my other question is sort of from like a testing philosophy concern. So one thing you could run into when you're writing tests is like if your tests are super complicated, you can have a bug in your tests themselves. So how do you reconcile that with like an approach where you might be specifying the inputs via regex itself, or how do you basically reconcile both of those things?
That's a big question.
Mm-hmm.
Yeah, I think I ran into this before where like you basically have like 2 sources of truth, one of them being the actual code that you run and one of them being like the test harness. I think this goes back, I think, to my original point that like hypothesis and product-based testing should be combined with other like best practice like software engineering, like I think development workflows. So like if you have like a very complicated workflow, I would consider like breaking that up into like smaller like bite-sized chunks, and seeing whether or not you might be able to test each chunk independently of say the next chunk, for instance. And that way, like you might be able to get more test coverage and ensure, I guess, more reliability because you're able to I guess capture the complexity at that level within your mind. And it also helps, to run, I think, more tests in parallel because you have more chunks. Does that help?
Mm-hmm.
I'm gonna jump in
On
here
the topic. I'm sorry.
Oh, sorry, Rod. I was just going to jump in here because we've got about 5 to 10 more minutes. Etan, it looks like you had posted a question, and then Zach, I think you had one as well. Just wanted to give you guys a chance if you still had those or if you feel like those got answered thus far.
I think somebody managed to answer my question when they mentioned that it logs a bunch of seeds for failures.
Awesome. Okay. Good. And then I know in the chat, looks like you kind of responded to Zach. Zach, did you want to voice yours or are you good too?
No, I'm fine with that question. I did have another point I wanted to bring up
Sure, yeah.
about operational telemetry. I work with, on a side project, telemetry from a GPS receiver, and I'm working on telemetry visualization. So validating all those GPS packets coming in. So from what I'm gathering, I can build a custom hypothesis module to generate valid strings of GPS tracks on the fly and then put that into a strategy, I guess, right? I can extend that. That's really powerful if that's true.
if you have a good pattern to go from, yes, that's probably the easiest way to do it. And with GPS, it's usually just coordinates, so that's just numbers, and numbers are very the strategies they have for numbers are fantastic. Like literally the first thing you want to do when you're playing with hypotheses is poke around in strategies submodule, because there's a whole collection of things, and if you don't look in there first, you're going to end up reinventing a lot of it. So don't bother, just look in there first. And then just about every strategy has a method called .example. So you just pick like hypotheses dot strategies dot let's say complex numbers, and then you do .example. And if you keep running it like in IPython or something, or in Notebook, you will see that it will keep generating different examples. So if you find a type that fits whatever you're trying to generate, like if you're generating GPS, that's usually what, tuple of 3 floats, right?
Yes.
So you can just generate a strategy that's literally a float. It's the outer would be a tuple and the inside would be a float. And there's your own sort of very basic your own strategy, and it will just keep generating examples. So once you have that, you just feed it to your whatever is consuming it, and it works. It's wonderful.
Very cool. We probably have time for 1 or 2 more questions if anybody had anything else they wanted to bring up.
Well, I think I might have forgot to add this in my presentation, but I think our company, the company I'm working for, Motor Refi, I think we're actually hiring for certain positions, and I think we're also hiring through Hatch IT as well. So if you're a full stack engineer, or if you're like a technical data analyst, or you have friends or personal contacts who are, just feel free to give them a mention. We don't use Hypothesis or Python too heavily. At my company right now is mostly like Ruby and TypeScript and functional programming. But we generally try and follow like best practices. Like we're currently moving to the Kubernetes right now as part of our like monolithic microservices transition as we're building out our engineering team. I think the teams are pretty smart in general. So yeah, that's a shout out, I guess.